Hello, my name is HPena. In this presentation, I will review Module 6 Algebraic Thinking, Task Implementation, and our reflection. Let's dive in. So our assignment goal was to um, analyze two individuals' thinking while completing the toothpick square grid task, which is the activity that I decided to implement. The goal was to observe their approaches, identify misconceptions, and evaluate their performances using the mathematic understanding rubric that was attached to this week's module. The analysis helps me inform instructional strategies for teaching algebraic reasoning in my middle school classroom. The description of the toothpick square task. The task involved a growing square grid pattern, which the first figure was a 1 by 1, 4 toothpicks. The second is a 2 by 2 grid, 12 toothpicks. And the third is a 3 by 3 grid with 24 toothpicks. Students were asked to find a rule for the number of toothpicks for any stage. The correct rule was T of n is equal to 2n times n plus 1, which accounts for n plus 1 horizontal and n plus 1 vertical lines, each with n toothpicks. This is a challenging activity because students assume simple linear rules like 4n or quadratic rule like 4n squared, which was neither. Some observations and my rubric ratings included, so participant A was a 14-year-old algebra student. A friend of mine has a student in my accelerated course. They counted correctly and created a neat table of values for 24. However, they gave the formula such as 4n and then 4n squared, reasoning that the grid was a two-dimensional. They did not identify the correct structure involving rules and columns. According to the rubric, I scored participant A with procedural fluency of 2, conceptual understanding of 2, and problem solving a score of 2. These ratings reflect partial understanding and some correct procedures, but inaccurate translation to our symbolic form. Participant B Participant B was a 22-year-old male with limited algebra experiences. They struggled significantly. This 22-year-old, excuse me, only has a high school degree. They initially guessed 16 for the second figure, assuming each square required 4 toothpicks. After corrections, they tried formulas like 4n minus something, but never organized their work or created a complete table. The approach was largely guesswork. The rubric rating I felt were for procedural fluency a score of 1, conceptual understanding a 1, and problem solving of 1, indicating major gaps in understanding and ineffective strategies. Differences and common struggles between both participants included they struggled to generalize the pattern correctly. Participant A showed partial insights into two-dimensional growth, but misapplied it, right? So they knew that the structure mattered, but they couldn't apply it correctly. While participant B remained anchored in linear thinking, that was their only experiences. In high school, a common issue was ignoring the shared side and failing to recognize the structural basis for the correct rule. These observations highlight the need for explicit instruction on pattern structures and representation. So some instructional strategies in case I were to implement this activity in my classroom would be to definitely implement hands-on activities using actual toothpicks to build grids, making the structure visible. Multiple representation would be perfect. Diagram, table, verbal, algebraic would guide students through systemic reasoning. Emphasizing rows, columns, and the n plus 1 lines in each direction helps our students see why the rule T of n equals 2n times n plus 1 works. Additionally, contrasting linear and quadratic growth patterns, providing sentence frames for justification would definitely strengthen our conceptual understanding. I do want you to note that my students have not seen geometric sequences, so this one was a very difficult practice for them. And then, of course, we would practice with related contexts, such as a fence post or tile border problem, so they can practice area versus perimeter. I want to thank you for watching this presentation. It was a very fun activity to implement for both age groups, one in a current accelerated algebra blended class, and the other one a 4 years graduate who hasn't taken algebra in probably around 8 years, and seeing the differences in their approaches was very insightful. So thank you, and we'll see you all next week.